Hello, it is Mr. Orgic again, and you are watching Unit 3, Lesson 6. Today we're going to explore rate of change, and you have seen this before in 8th grade. So here we go. Example number 1 says that Max and Evie basically are in the backyard. They're going to have a race. M of t is Max's distance over time, and E of t represents Evie's distance over time from the start. Okay, all over time. So we're going to take a look at what's going on here. The first question, part A, states that m of 12 is equal to 30. So what I want you to look at is m of 12. That means Max at 12. T, remember, stands for the seconds. This is also stands for this part right here is your input. This part right here is your output. So we're going to go to 12 seconds over here. And if I go down across the bottom here, here's your time. Here's 12 seconds. I'm going to go up. Here's my M of T line, which I made Max green right here. And if you go across and you read it, sure enough, it's right here. Each one of these bars was worth 5 times. So there we go. That's 20. That's 30. So that comes up with that. So what does this whole thing mean? Yes, it means basically that after 12 seconds, okay, so after 12 seconds, Max has gone 30 meters. Okay, that's what that stands for. After 12 seconds, Max has gone 30 meters. So if you got an input of 12 seconds, output will be 12 meters. All right, part B says, how much of a head start does Evie get? Well, once again, we're still taking a look here. Max is at 0. Evie starts off ahead, so she's not at the starting line. She's already up here, and if you look at it, 10, 20, and that will be 25 meters. So the bottom line is Evie is up here at a 25-meter head start. So she's not starting, and when the 0 time starts, she's 25 meters ahead of Max just to start with. All right, then we go to part C. It says, does Max catch up with his sister, and how can you tell? Well, there's a lot of ways you can explain this. Take a moment and just pause this video and take a look and see if you can explain it before I do. Okay, one moment. All right, welcome back. Let's see what you said. My obvious choice here is if you take a look, here's Max's, here's Evie. Okay, it only goes up to 20 seconds. Did they ever cross? And the answer is no, they didn't cross. The bottom line is no, they didn't cross. You can explain it other ways than that. You could take a look that said at this point they've never gone. Evie's gotten up to here, way up here. She's gone 60 feet or 60 meters here at this point at 20 seconds. Max is up to 50. You can explain it that way. But the bottom line is no, they never crossed. Okay, so fill in your answer in here. I'm not going to write that down because my sloppy writing won't fix it anyways. But bottom line is the two lines never crossed, so therefore Max never quite caught up. And if you take a look, it does look like he's getting caught up, though. He's a lot closer than the beginning. Remember, they're 25 meters apart. Now they're only 10 at 20 seconds, okay? Keep that in mind on the next slide. All right, we're going to take the information, what we're just doing, and figure out a few more things. It says in part D, it says, how far do Max and Evie run in 20 seconds? Well, Max isn't too bad. You know he ends up at going 50 meters if you go back to the chart and take a look. Where did he start at? 0. So what's 50 minus 0? It's 50. So the bottom line is Max went 50 meters. Then if we take a look at Evie, this is a little tougher here. You got to be very careful. You know she ended up at 60 meters after 20 seconds if you read the graph. But she did not start at 0, did she? Max gave her a 25-meter head start. So if you take 60 minus 25, you've got Evie actually went 35 meters, okay? Now we're going to take that information and we're going to move on to question E here, okay? And we're going to talk about Max's speed and Evie's speed, and this is what they call average rate of change, okay, which is going to be speed in this case. Well, I need to go back a little bit for you, and let's go back to middle school. And if you remember the old formula, distance was equal to rate times time, okay? But we're going to solve for speed here. Speed, of course, is going to be the key that we're looking for, and that is going to be out of those three variables, your rate. Well, the formula D equals RT doesn't help me, so let's go back to the last chapter with literal equations. In literal equations, we move stuff from one side to the other. So I want to know what R equals, not what T equals. So how do you get rid of that T? You guys know it. Divide by T. So if I do that, I rewrite my formula such that the rate is distance divided by time. All right, so I'm going to change colors here. We're going to go take a look at Max now. So Max's rate, if I take a look at it, we know his distance was what? Well, if I come back up here, he was 50 meters. And over what time did he go? Well, the race was over 20 seconds. So if I divide 50 by 20, Max actually turns out to be 2.5 meters per second. I want you to pause the video for a second. I want you to try Evie's. So I'm going to wait for you a moment. Just try Evie's rate of speed. All right, welcome back. Let's see how you did. Evie, as you know, went 35 meters up above, and you're going to divide that one also by 20 seconds. And you should have gotten a rate of 1.75 meters per second. So take a look at this real quick. I just want to sum this up. Take a look at their speeds. Here's Max's. Here's Evie's. Who's running faster? Obviously, Max is 2.5 compared to Evie's 1.75 meters per second. And go back and just take a look at that graph too. Who had the steeper line? Max. That means he's running faster. That's the greater speed. All right, time to move on to question 2. All right, in question 2 here now, it says you're going to find the average rate of speed is the same thing as finding what? Well, you should remember from last year that is called slope. So I'm going to fill that in the blank here. That's actually finding the slope of the line, okay? And you might also recognize notation here. I got you the star of this here. You might want to put this in on your paper in your packet. You've got the average rate of change there in a box type thing. I also you might want to answer put it this way, because they put this whole function notation f of b minus f of a all over b minus a. You guys might recognize it as this. M is equal to y2 minus y1 over x2 minus x1. The difference in the y's, which guys keep in mind, that's the difference in the outputs over the difference in the x's. That's the difference of the inputs. So that's the formula we kind of use when we're doing linear and range change of slope. But they're giving you the general function one because we're going to go away from just doing linear equation. All right, on to the next page. All right, in example 3 here, we're now actually going to do rate of change with that big formula they just gave. Same thing as the one I just talked about. And they've got some functions here, and they tell you basically want to find the average rate of change given the function x squared plus 3. That is no longer linear. The squared tells you it's another form. You guys will know it as a quadratic as we get through the year. The average rate of change, they want to go from here, and the x is -1, to x is -3. Well, that, guys, is your input, and the input are your x's, and they go in the bottom here. So I can already fill these right here in the formula. I'm going to do 3 minus a -1. So what are we missing? We got to find what f of 3 is, the output for 3, and the output for -1. So that's where we're going to do a little work right now. All I have to do is plug them into the formula. So if I take f of 3, all I'm doing is taking 3 and squaring it, and I'm going to add 3. Well, what is 3 squared? 9 plus 3 is 12. I'm ready to jump all the way through it. So that's what f of 3 is. I want you to pause the video, and I want you to find f of -1 right now. All right, welcome back. Hopefully f of -1, let's see what you did. Remember, you're squaring the entire -1. I'm going to put it in parentheses. That's critical. If you don't do that on your calculator, you're in trouble. So if I square a -1, we know -1 times -1 is 1. 1 plus 3 is equal to 4. So now we have our two key pieces. All we have to do is the math. So I'm going to change colors so you can see this again. Up here, if we go to our formula, f of 3 turned out to be 12. So I take 12 minus f of -1 turns out to be 4. And that whole thing is over 3. Notice minus a -1 right here. You got the double minus sign right there. Clean that up. Okay? So that's really 3 plus 1. You do the math, you get 8 divided by 4. And our average rate of change is 2. We don't know what that stands for, but that commonly is known as your slope, and in this case we're calling that the rate of change. All right? We're going to move on to the last 2 questions, so hang in there. All right, in exercise 4 it says find the average rate of change from the interval from interval 2 to 6. That means bigger than 2 but less than 6, and we're going to go in that part only. So they're only looking at a chunk of what would normally be possibly a line or whatever the function is. We're not looking at the entire function. So all you have to do, once again, is do what we did before here, except it's easier. You're going to read off a table. So if I take a look here, remember you're talking about you're going to take your, in this case, you want to go from 6, so we want h of what would turn out to be 6. Going from 2 to 6, so h of 6 minus h of 2. And that whole thing is all over the 6 minus 2. Those are our x's once again, your input outputs over your inputs. Well, the bottom's easy. 6 minus 2 is 4. How do I get h of 6 and how do I get h of 2? Well, go to your table here. Here's h of 6, right? That's the 6. What is the output for 6? It's a 3. So just replace that with a 3. Minus, if you want input is 2, what is that output? It's a 9. So I get 3 minus 9 over 6 minus 2. 3 minus 9, of course, is negative 6, divided by what would be, turns out 6 minus 2 is 4. And you could reduce that to negative 3/2. Bottom line, that is our average rate of change on this function. And that's all you have to do. Table is actually easier. We didn't even have to do too many math calculations, okay? All right, you got one final exercise, number 5. So I am going to have you do that tonight. We're going to write a nice WSQ for us. You are going to do exercise 5. And remember, if you don't, you're going to lose points in class tomorrow when we're checking your homework, okay? You should be off and running. This should be an old topic you know is slope, and we're going to explore that with various functions. You can do it with any function, and that's your average rate of change. Just the difference in your outputs over the difference of your inputs. Have a good one.